questions like, what is the recovery level of a place? Are we getting closer to our initial goals? Or should we change our restoration efforts? We can do all this and improve our restoration plans and techniques in order to achieve our initial goals. It's possible, and that effort is more cost effective. So according to SER, to the SER primer, that is used for definitions in restoration, as you all know, they talk about success evaluation in these three types of evaluation. The first one is by direct comparison, where you select several parameters and you compare them in the restored site or in the site that is being restored and the reference site. But the problem with this technique is that the chosen parameters should be standardized. Because sometimes you are studying one component and in another place they are studying another component, and then it's very different results, and it's hard to compare each other and to see and to have information available for everyone. The other option is the trajectory analysis, in which you try to identify trends so that you can see for what is happening in the last years. You can try to
Yes.
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 To guess what's going to happen in the future, and then you can also change your efforts and see what you can do to get it better. And the other option is to analyze the attributes that SER established to set a site as restored. And these attributes, as you all may know, are these 9 attributes. They are related with species diversity, with the presence of autochthonous species, the presence of functional groups, the presence of reproducing populations, the ecosystem functions, the abiotic and biotic fluxes between the restored site and the nearby areas, the elimination of threats like invasive species, the resilience of the restored sites, and self-sustainability. Here we will focus on the first 3. They are related with biodiversity. So our main goal for this part of the project was to evaluate the structural and floristic diversity of vegetation in Cecilotone property. Additionally, we had a first approach to the evaluation of animal communities, namely beetles and small mammals. I will start with plant diversity. So this is the total area of Cecil. So we chose different sites inside the quarry, both quarries in marl and limestone, with different ages, which are here, you can see with the arrows. Then we chose reference ecosystems, both again for limestone and for marl, and we also did the evaluation in sites that were burned 5 years before this study. We also chose other nearby areas because they can also be important to the recovery of the quarry. I gathered some pictures just for you to see how that is. So here in the limestone quarry on the top, you can see that they are platforms. So you have basically a road with trees on both sides and shrubs, and they only established shrubs and tree species. On the bottom you have the marl quarry. In this area that was older, they also have platforms, and they did the restoration the same way that in the limestone, but here you can see that they have slopes, older slopes with shrubs and trees, and younger slopes that here you can see, but they already have shrubs too, but they are really small. well, these areas are important because they give us information about communities after intervention. Here you have our reference sites, the limestone with the limestone outcrops that Graça was telling you, and the marl, you can see it very well because it's too dark, but it's the type of vegetation is the same of the limestone, but without the outcrops. These ones are the reference sites with no intervention for 50 years. The label is wrong. And these ones are the sites that burned in 2004. You can see that the vegetation after only 3 years is well developed. We study these areas because we consider them model areas for our recovery actions. And these are the other areas that we studied. We have pine stands with different pines from the ones that we found in the quarry, because there used to be plantations from, if I'm not wrong, from the quarry until Setúbal, but old plantations. And we also had a riverbank area that was inside the property, and we were interested in see how it was in terms of conservation. Oh, they are important because they also have the potential for species for colonization of the reference for the restoration sites. Well, here I have a table with our results in terms of species and diversity. It's a huge table, but just to point out that, as you can see, here it's the natural site, this is the burned area, and these are the restored sites in the 80s, 90s, and after the year 2000. As you can see, the diversity index, it's not so different, and you can see an increase in the index from the oldest sites to the youngest. But when you look at the species assemblage, you can see that the similarity, even if it's not too big, it's increasing with time, both in limestone and in marl. Just to give you an example, because it's too much data, I'll talk about the limestone area, where we found 78 species. From these 78 species, 69 were found in the quarry, and 54 were natural colonizers, which means that the rest were planted. But yes, the rest was planted. We saw similar total plant cover in all sites. It's the orange bar here with the arrows in blue. As you can see, with age you don't have much difference. What was the main difference was when you look at the different layers of vegetation. If you can see here, you have herbaceous species in yellow, and you see that they decrease in cover with age. And you have shrub species in blue, and they increase until the 90s, but then in the 80s we have a smaller value, but I will explain that. And you have the tree species that increase from the most recent place to the 90s, and then again in the 80s. Well, this is because we planted Pinjal pensis, which is used all over the Mediterranean basin in restoration. And in the 80s they used to plant a higher number of plants in the platforms. So they form a canopy, a more dense canopy, and it's more difficult for the other species to compete. So, now a brief conclusions before I pass to the other part. We saw that native species using revegetation seems to accelerate natural colonization of disturbed sites. In limestone, the presence of the pinjal pences was the main difference between the reference site and the restored sites, and also the absence of Revegetated, which is a species present in high cover in natural sites, but that we have slightly problems in getting it in the quarry. In Marl, the main difference was due to species introduced by hydroseeding, namely in the more recent sites. We had a total of 189 plant species, which represent 14% of Serra da Arrábida, Florida, and we also found some endemic and protected species that add value to our sites. Now I will pass to the animal diversity. As you all may know, most studies used to focus on plants and soils when they talk about restoration, but in the last years they are more focused on all the restoration of all the ecosystems. So they are now trying to study other components. Although vegetation and soil are still more traditional study. But animals play an essential role on several ecosystem functions and mechanisms, like seed dispersal, pollination, and soil modifications. But usually they have a big problem that we need more time to study them. We need more resources and experts and more money, as with everything. So our main goal was to try to improve our traditional vegetation directed to sex evaluation by adding an animal group, but without increasing their complexity, the study complexity and resource demand. So we chose beetles and small mammals. And we only did this in the limestone quarry, in 3 different sites inside the quarry and in the reference area. The study started in the same year that another university, Universidad de began their study there with fauna also, and they studied all the property as we did with vegetation, but my work was only in the limestone quarry. So, beetles. We identified the beetles until the family level because I don't know if you have experience with insects, but you need an expert almost to each family to get to the species name. So we just stayed with families. We identified 37 families, from which 32 were found in the planted sites. We had a higher number of families and diversity in the reference sites, as you can see here. All trophic groups were represented. I didn't show here, but we tried to put each family in one trophic group according to bibliography. And we saw an increase in abundance with time, as you can see. Then we had one expert in Carabidae family, so these ones were identified till species level. We found 28 species, 19 in planted sites. We had higher abundance of all species in the reference sites, and most species were represented by 1 or 2 individuals, which was a problem because we can say if they are there because they want to be there or they just got there by chance. Then, with small mammals, we found 4 species. All species are common in Serra da Arrábida. They are common species elsewhere. Epidermis sylvatic, which was the most abundant species, it was found in all planted sites. Mustretus, was found only in reference in more recent sites that has higher cover of earth of herbaceous species. And COST ES1104 that was mainly found in reference sites and in the site that was planted in the 90s, the site with more shrubs cover. So, to put it all together, we found that there are several things that point out in the direction of what we consider the reference for our restoration. In plants, we have the total vegetation cover that is increasing towards our reference site. We have a decrease in herbs cover, and we have new species, both plants and natural colonizers. Beetles, the evidence is also increasing, and its number is similar to the reference site in the older site. Most families were found in all sites, and all trophic groups were present. Concerning the small mammals, all species were found in the quarry, and the presence and the abundance were related with plant cover. On the downside, herbaceous species and cover is still high in some quarry sites. And we have a higher tree cover in planted sites because we have kingal fences, which is not common in the natural sites. Beetles still have higher diversity in reference, and the composition of the families, although they are all represented, it's a little bit different. And small mammals, they are more related with the habitat, so not all habitat requirements seem to be present in all sites. And now to finish, so our goal was to improve the traditional vegetation evaluation without increasing complexity, and with 3 months of field work, but with a lot of months of lab work, we could see that beetles identification till the family level can give information on natural colonization and can give some information on trends in abundance over time and some insights on trophic structure. But when we saw just the Carabide till species level, we have information on natural colonization, but most species are only represented by 1 or 2 individuals. Small mammals can give information on natural colonization, but we need more time to set aside population fluctuations. So we think that beetles identified to family level was the best complementary group. It was mostly informative and practical, and it's not so difficult to do. Thank you. It's all.